Okay, so welcome back to C Sharp. What we're going to do now is we're going to talk a little bit about what I've been referring to as thick clients. So to reiterate, what a thick client is a desktop application that has a substantial amount of business logic in it, and that business logic communicates with a server somewhere, potentially, and the thick client requires your actual machines, your desktop or your laptop or your phone or whatever, to have a substantial amount of resources in order to run the app. So if you think about something like a video game, you could have a video game that has a really high number of system requirements in terms of memory or storage. And by shipping some of that processing off to a server, you can lower those requirements. Thick clients themselves have larger requirements for client machines than thin clients, and that's essentially where they get their name. So in the wide world of C# application development, the new sort of way of doing thick client development is through a framework called the Universal Windows Platform, which is what UWP stands for. You'll see it sort of all over the place. This is a new way of doing it. The previous way was called Windows Presentation Foundation, or Windows Presentation Framework. And the syntax is actually exactly the same. The only thing that changed is that instead of using .NET Framework, this is using .NET Core. So we've very recently migrated this whole module from .NET Framework to .NET Core, so that people working remotely on Linux machines or on Windows or on Mac can still participate. So you should be able to open this example code on your Mac and run it as if it was on a Windows machine. So that's the core difference. If you're looking for a job and people are talking about Universal Windows Platform, that means that they're using the cross-platform version of thick client development. If they're talking about Windows Presentation Foundation, that is the older kind of Windows-specific version of thick client development. Truth be told, if you're looking for a job and you are set to work on a thick client in C#, that is most likely a legacy system. There are some thick clients out there. So Spotify, for example, has a desktop experience that you can actually go through and click on things and whatever. A lot of the Microsoft Office suite still has a desktop experience, so you can download Office 365 and run it natively. It is essentially the same as the Office 365 in the browser experience, but by and large, thick clients themselves are being deprecated all over the place, and the reason is that cloud computing has made sort of thin client browser-based experiences way more attractive, because you could run this same application across any number of devices in a browser, and you're going to have very minimal resource requirements for a browser-based application. So all that said, we definitely want to take a look at thick client development, and the reason is that it's sort of the logical next step on top of sort of console apps that we've been doing in the past. So here what I've got is a really simple UWP app that is a stopwatch. And so I'm going to run it really quick for you to get an idea of what it does. And it's certainly not groundbreaking or anything. It's going to generate a stopwatch, and I'm going to be able to start it. It's going to run until I tell it to stop, and then I'm going to be able to restart it back to its original state. So what we want to do is we want to talk about how all of this kind of hangs together, and use this as a starting point for showing you how UWP data binding works. So I will put a link to the sort of ideology or the philosophy around data binding into the Canvas page. Suffice it to say that it is much more convoluted than the binding story around JavaScript for Angular or for React. And if you don't necessarily immediately understand it, that is entirely okay. By looking at the videos in this module, you will have at least a working knowledge of what is happening, and that will usually get you through 95 to 99% of all the kind of use cases you'll see. So if we go back to the code, I'm going to briefly show you how to actually generate one of these things. So when you create a new project, you want to run as administrator, and then create a new project. And the template, once it loads, is going to be a blank Universal Windows application. So up here you can actually type UWP, and then you can see blank app for Universal Windows. You certainly don't want the VB version, so Universal Windows for C# is what you want. If you're on a Windows machine, you can actually do WPF. So a WPF app for .NET Framework will do exactly the same thing. You can also use WPF on .NET Core, so this is also theoretically cross-platform because it's using .NET Core. The difference between .NET Core WPF and true Universal Windows Platform is Universal Windows Platform builds the application into the store. And so by virtue of being in the Windows Store, you can port it to not only laptops and desktops running Windows, but you can also port it to Windows Phone if you choose to do so, or to things like Xbox that might tie into the Windows Store. So WPF apps are just executables. UWP apps are executables that you can't actually run by double-clicking them. They have to be installed from the Windows Store. So that's kind of the ramifications of choosing either or. There are also kind of known issues around WPF apps in .NET Core not doing or not supporting specific use cases that might be common. I have not really used .NET Core with WPF very much. Like I said, it's sort of a dying concept to begin with. I would stay away from this if I possibly could. So we'll clear that. So in WPF and UWP, the application is set up in the same way. So what you'll have is you will have a bunch of XAML files, and these XAML files work exactly the same way that HTML files work. So these XAML files are all of the UI, and these things will be bound to a .cs file that is called the code behind. So this page is an XML or a XAML file. So XAML is a special flavor of XML that was created by Microsoft to be declarative sort of markup language for their UI. And the code behind itself is just C#. So we've got a view, if you will, and we've got a controller, for lack of a better term. And so we were going to talk about different ways to structure this kind of stuff, but that is going to be in a subsequent video. So for right now, what we're going to do is we're going to consider this main page to be our UI, and the code behind to be the behavior that sits on top of that UI and makes the UI actually do stuff. So our business logic is going to be encapsulated in the CS file behind the XAML file. So here, what we have is a grid. So the other main difference between WPF and UWP is that UWP uses a page tag. So everything inside of the application, if you have multiple screens, for example, those multiple screens will be called pages. And WPF, they're called windows. That is more than just name. So the functionality of a page is fundamentally different from the functionality of a window. And so if you are tasked at a job to convert WPF code into UWP code, you do not want to copy the Windows stuff. You want to take the inside grid. And so in XAML, the grid control is basically the de facto layout control. And what it allows you to do is build a grid-based UI. And so we'll look at this a lot more when we build a calculator in a couple of videos. But for now, this is basically just a container. So if you're familiar with HTML, this is the exact same thing as a div or a span. And then a stack panel, what it does is it enforces this sort of top to bottom floating. So here we're going to have a stack panel. That stack panel is going to, stack each of these controls. So the first one is a text box. This text box is going to have a whole bunch of properties. These properties are, again, exactly the same as sort of style properties on HTML. The thing that is fundamentally different is this guy. So here, what we're doing is we're binding the text property of this text box, which is what you're going to see in the text box, to a property in the code behind. And so this property on the code behind is going to be called time. So time is going to be the name. And if we go to the code behind and we look for time, we indeed have a property. And that property has a getter. And that getter is going to be what formats the time that we see. So we saw this kind of formatting when we ran the application. The formatting comes directly from this property that we are bound to. Now, this goes back to one of the kind of foundational things that we harped on a lot in the syntax part of the course, and that's the difference between a property and a field. So here, if you try to put a field into the binding for any property, you're not going to be able to do it. And the reason is this binding actually happens via the getter or the setter, but in this case, the getter, because it's a display property. So we need for this to be a property. And what we're going to do is we're going to say that we want to update this UI each time this property time is changed. So that is going to bring us back to this implementation over here, which we're going to talk about in just a second. So there are two main things we want to talk about here. The first is we're going to bind to the property name that is going to be on the controller, or also called the data context. And in this case, the data context is just the code behind. And we specify the property name here, which is time. That maps to a string property over here called time, and we're done. And because we want to make sure that the time updates on the face of the stopwatch each time we tick through an additional millisecond, we want to make sure that this property up here bound to the text box is updated every time the underlying property changes. This mode one way means that it's not going to be possible for a person to click into the watch face and then reset the time to something arbitrary. That would be two-way binding. So not only are we binding from the code behind to show you the value, we're also going to allow a user to enter data into the field and then carry that down into the property. So this is only going to be a one-way binding from the code behind's property to the actual control that we're looking at. So everything else on this is a button, and so buttons are less convoluted, and really everything about this is going to be managed by events. So we talked a little bit about events in the final series of pages and videos about syntax. And so here what you're going to see is any kind of event on a control. You can specify the name of an event handler, and that event handler name is going to be a delegate, and that delegate is going to be picked up in the data context. And so back over here in our data context, which is again just our CS file underneath XAML file, we're going to have these click events. So we're going to have start click, stop click, and reset click. These are going to be bound to the start, the stop, and the reset buttons, respectively. So that's really it for the XAML. There's nothing kind of rocket science-y about it. The complicated stuff happens in the code behind. So what I want to go through is first the fact that this property is really the only property that's on this entire data context. It's the only thing that we care about from a data sort of state perspective. What we have aside from this public data is we have data inside of the class that is sort of private, and it is only used to implement the actual stopwatch's inner workings. So that's how we're going to actually keep track of the time. So in the constructor of each of these pages, if you have main page and then a whole bunch of child pages, each of them will have its own constructor. That constructor will always call initialize component, and the page itself is inheriting from this page base class. That base class has a thing called data context. That data context is an object, and whatever you set to be that data context will be what all of your click events and whatever have to be bound to. So because we are setting the data context to this current class, that is what is making it possible to bind this property, this time property, to the property on the code behind. This line of code right here will change if we want to implement what's called MVVM, which is another thing that we're going to talk about a little bit later. And that is to allow you to sort of abstract all of your business logic away from these generated or kind of attached classes and put it in something that's more reusable, so that if you do have a thick client, you can actually take that business logic and you can work on distributing that out to some server-side proxy. And at that point, you can actually replace your thick client with a thin client on a mobile app or a browser-based web app, or God knows what. It's just a way of extracting the business logic away from this like tightly bound class and into something called a view model, and then you can set the data context to be that view model, which allows you to decouple the UI from the behavior. So outside of that, what we're doing is we're creating a new stopwatch and we're creating a new dispatch timer. So the difference is that stopwatch is going to allow us to keep track of time. The dispatch timer actually has an event that we can tie into that every time we experience a system clock tick, we will raise this event. And so this event here, tick, is going to subscribe to this dispatch timer underscore tick event handler. And so this delegate is what's going to actually change this current time span private backing field. Then that private backing field is going to be formatted in the public getter of our string time property. So what is happening is when you first create the stopwatch face, we are creating a stopwatch behind the scenes that allows us to compute how many milliseconds happen between each of the start and stop clicks. And then we have a dispatch timer that allows us to update the watch face in step with each of those sort of millisecond rollovers on the clock. So this will kind of make sense if you read it a couple of times, except for one thing. And that one thing is this interface right here, iNotify property changed. So if you remember back here, binding to a property makes total sense. This part is the part that may or may not make sense. If you look at the sort of implementation of iNotify property changed, what this thing is allowing us to do is tie into another event, and that event is what's going to cause this text box to update the UI every time the event is fired. So by virtue of implementing this interface, we have the requirement to implement this method down here. And what's actually going to happen is every time a property is changed, we are going to be able to call notify property changed, and by virtue of passing in the name of the property that has changed, anything that is bound to an update source trigger of property changed on that name will get notified that it needs to repaint its part of the visual tree. So the visual tree is basically this XAML stuff as it's rendered on the client side. So it's all the stuff that's unhidden, essentially. And so this notify property changed is tied to this interface, and any class that implements this has the ability to raise to the UI that something has changed and that bound UI element needs to re-render. So we need to redraw the text box and notify that like another millisecond has elapsed. So if we run this thing one more time, each sort of clock tick of the dispatch timer, what's happening is we are updating the stopwatch. That stopwatch is driving the private backing field for the current time. And then we're also raising a property changed event on the public time property that is telling UWP that we have to redraw this text box. So this is fairly responsive. So even though we are constantly, every millisecond, firing an event that this text box needs to be updated, we do not see any sort of performance impact. That's completely segmented away from us. And so that is the power of the iNotify property changed event, or the iNotify property changed interface. So that is probably the most misunderstood and not implemented correctly part of data binding. And we're going to see some examples that are a little bit more complicated, and I think that that will make a little bit more sense. So I hope that this kind of serves as an introduction to thick client development for C#. It is not necessarily brain surgery, but it does have some weirdness in terms of syntax, particularly when you're trying to bind data on your data context to the actual UI itself. So I'll be back with a couple of additional example applications, and so I'll also be uploading this example code. And so please take a look at the example code, and one of the things that you might want to do is try to implement features inside of these applications just to prove to yourself that you know what you're doing. And so I'll also post a small list of challenges for each of these examples just to see what you can come up with. So thanks very much for tuning into this video, and I will be posting the next one shortly.